domain of a square root function includes only those values for which the radicand is greater than or equal to 0. So yesterday we talked about setting f of x, which is what's under the radicand, greater than or equal to 0. The value of the domain is used to determine where the range value will start. And then we say that it has a maximum or a minimum at that hk, much like our vertex. So that starting point of your square root is at that hk, shift right or left, up and down. So it says the surface area of any sphere can be found using the formula 4 pi r squared, where a represents surface area and r is the radius of the sphere. Solve the function for r and then graph it to state the domain and range of that radius. So if a equals 4 pi r squared, and we wanted to solve this for r values, we would have a divided by 4 pi equals r squared. To get rid of something squared, we take the square root. We know that when we take the square root, we take it with a plus or minus in mind. Why would we not include the negative in terms of this problem? So a radius represents a length. Can you have a negative length or a negative radius? No. Go into like some area and beyond. So we would say that the radius is represented by the square root of a over 4 pi, where a in this case is kind of like represented by my y. So if we're graphing it on an xy plane, the a is where y would go because that's the alternative variable, and the r is where x would go. And if you graphed it invertedly, that would also work. By graphing it like this way, it makes it that's going to end up looking like a graph. But if you had graphed it the other way, you would look like a square root. So you could graph it either way, you just have to make sure you label your graph. Does that make sense? Like how I labeled the a and the r? So if you had labeled it reverse and you put r up top and a on the side, that would also work. So if we're talking about the domain and range of these functions, we should know or understand that both the radius and the area must be greater than or equal to 0. Never going to have a negative area. And then to graph our curve, we just start picking values. So 0, 0. If my r value is 1, then my function area would be 4 pi. Pi is 3.14, so 4 pi. Part B is a follow-up to that. It says, find the radius of a sphere. So we're looking for r, whose area is 30. So we just said that r is equal to the square root of a divided by 4 pi. Anytime you're using pi, you're just making it on your calculator that pi symbol. So 30 divided by 4 pi inside our radical. gives a radius that is approximately 1.54. And there were no units given, so we cannot attach like inches or anything to it. If it's radius, this would be units. If your answer was area, it would be units squared. Example 8, describe each transformation and then graph. So we have an inequality. The -1 tells me it went right 1. The +3 tells me it went up 3. It is not stretched, compressed, or reflected because there is no A value. So all of my X values get shifted 1 unit to the right. So those original points, 0, 1, 4, 9, all move right 1 to become 1, 2, 5, and 10. All of my Y values that are 0, 1, 2, and 3 get moved up 3 units to 3, 4, 5, and 6. The graphing is solid because it is equal to. The Y values are less than, so Y is less than below the curve. Yes.